My name is Christian Fekete, and I'm based in Hungary. I'm member of database development organization, and more specifically, I'm member of RAC team. Our team works with strategic customers, but behind the scenes, we also work with development organizations closely. And also with support. I have been working at Oracle for 16 years and focusing on ODA for almost 8 years now. I joined RAC and started to work on ODA when the most up-to-date version was 12.128, and X5-2 was the latest model. So it was long time back. Today I will talk about high availability, as Maxim and Sylvia mentioned earlier, from a hardware and software perspective. I will cover many of the features that it offers from AJ perspective, and I will also demonstrate a few of them. So let's define first what high availability is. A compute node can fail for any reasons. The hardware can break, the network can break. There are software bugs, as one of our SVP said, if there is no bug in the software, then the software is dead because nobody uses it. So actually, if you have bugs, I mean, it sounds funny, but the software is alive, and in a weird sense, it might be a good thing. And also, a compute node can fail if we don't have sufficient hardware resources. A common example of the latter condition, known as out-of-memory condition, which occurs when one or more applications on the node consumes all available memory and no swap space is available. And also swap space doesn't really mean any good for databases, because if a machine is swapping, then probably you have very poor performance. A nice example for this out-of-memory condition, when, for example, you create many KVM application KVM guests, and the OS is smart enough not to allocate all the memory when you start the VMs, but eventually, if a VM needs the memory that was assigned to the guest, I mean, it keeps growing. And if you start too many, if you over allocated the memory, then eventually you will see in the messages log OM messages, and it will state that, okay, I killed this and that virtualized guests to free up memory. High availability is more important today than 5 years back, or even more. Database systems are more and more consolidated today. We have multi-tenant databases where one CDB hosts multiple pluggable databases. We have customers who have hundreds or even thousands of PDBs in a CDB. And also we have infrastructures that host databases and application guests on the same physical hardware. ODA is a nice example for that, because you can have the database on the ODA and also the application on the ODA inside the KVM guest. Also, the database can be on bare metal and inside DB system. We call it ODA solution in a box due to this option. When your systems are down or underperform, the business impact and visibility from end user perspective is much higher than ever. We can easily end up in newspapers if we cannot provide the regular service to customers. I mean, especially if we are talking about banks, the visibility is much higher. People can pay for their stuff in the supermarket, and that might cause some headache. So let's start with the hardware part, and let's go through what ODA offers to us from redundancy perspective. As you can see on the slide, many of the components are redundant, like we have two power supplies, multiple NICs, multiple disks, and so on and so forth. But not all components can be redundant. If CPU fails or memory fails, then at least we or the best thing that can happen, that we end up in a crash, and after reboot we get the oops, sorry, I pressed the button accidentally. So the machine boots up after the failure, and we have 64 gig memory less than before. But usually, if the motherboard fails or we have a CPU failure, then the node stays down. So that's the reason I'm covering ODA high availability model in this presentation, and not focusing on single node ODAs. And actually, that's what the maximum availability architecture also recommends. The Oracle best practice is to have multi-node racks and data guard configuration, and also asymmetrical architecture, so same hardware on the primary side and same hardware on the DR side, same number of database instances, and so on and so forth, because in case of an emergency failover, if you switch over or failover or switch over to a DR environment which has less resources than the primary, then you might expect surprises. So let's continue with the redundant components. ODA HA has two network cards in base configuration. One network card for the public connection and one network card for the private interconnect. The latter one is cross-cabled. I think it was visible on the slide that Maxim showed us earlier today. And regarding cross-cabling, just for your information, if you want to play with it, if you want to simulate an interface failure on the private interconnect by downing the interface using IFCFG down command, then you have to do it on both sides and down both, I mean, the same interface on both sides. Otherwise, one of the nodes will be evicted from the cluster. That is expected because, I mean, if you simulate the network failure with ifconfig in a cross-cabled environment, and you just down one interface, the interface on one side, then the other one still believes that the interface is healthy. Long story short, the the routing stays the same, and as we have active-passive bonding, and you down the active interface on one node, then the clusterware will still try to communicate through the active part of the bond on the other node where you did not touch the interface configuration, and as a result, as I said earlier, you will end up with a crash or eviction, not crash, because the eviction is something that we expect. Crash is not something that we expect. Bonds can be configured. The public network interface can be fiber with 2 ports, 25 gig ports, and you can also have copper cards with 4 10 gig ports. And as I mentioned earlier, ODA uses NIC teaming at OS level. So you cannot use these ports directly. We bond 2 ports together always, and they cannot be split on the ODA due to AJ and redundancy purposes. And that means practically the 2 fiber ports can be translated into 1 bond, and the 4 copper ports can be translated into 2 bonding interfaces. Bonds can be configured as active-passive, that's the default actually, or bonds can use link aggregation control protocol. If you want to use the latter one, then practically when you run the first configure firstnet command, it will ask you if you want to set the interface, the public interface, up with LACP. If you answer yes, then keep in mind that the switch side must be configured with LACP. Otherwise, they won't be able to talk to each other. The benefit of LACP is that, as I mentioned earlier, you can have 2 25 gig fiber ports. If you use LACP, it will provide you redundancy, but it also scales up the bandwidth because it aggregates the bandwidth of the ports. So eventually you will get 50 gig bandwidth. With active passive, it's just 25 gig, but I've never ever seen that somebody utilized 25 gig on an ODA, to be honest. So, I mean, it might be needed under very special circumstances, but it's very rare. Regarding the additional NICs, ODA X10 supports up to 3 network cards. I think that applies to X8 and X9-2. So these 3 public 3 NICs can be used for public communication, and that can be translated into 6 just a second 3 fiber based bonds and 6 copper based bonds in case of fiber or copper cards. If you have 2 or 3 network cards installed on ODA X9-2 or X10, before deployment, if you run configure firstnet, it will allow you to set cross-NIC bonding, which adds additional resilience to the network layer, and it provides better failure tolerance between the NIC cards. But while switching between active, passive, and LACP bonds is available pre and post deployment, cross-NIC bonding is only available before deployment. So if you deployed your ODA with one network card and you add additional network cards later on, this cross-NIC bonding won't be available for you. Okay, next slide. So let's continue with the storage part.
I'm sorry, Chris, there is
yes.
a question related to what you just mentioned, especially around LACP. I don't know if you can see it yourself or if you want me to read it out for you.
Sorry, the first one, not the second. If we use ODA with two NICs, is it possible to apply bonding or LACP between different NICs in the way? If you have X9-2, X10, X10, and you have two network cards, then cross-NIC bonding is possible. And as cross-NIC bonding is possible, it is possible to switch to LACP or set LACP for that bond. So that is possible. And there is another question. These AGA models shipped with copper NICs as, I'm not, I
think they're asking if they come with copper NICs by default or with fiber cards.
Honestly, I have no idea.
Yeah, so I can answer that. So basically, it depends on the customer needs on the network side of things. So they can come with with copper NICs if you use 10 gig, for example, you have RJ45 connectors, or we can also do the quote with fiber cards, and also depends on your network needs. So if it's 25 gig, 10 gig, we can provide the corresponding transceivers as well. So there is no default card per se, as in for the customer client side of things. We configure that depending on the customer needs.
Okay, so let me continue. So on this slide, I'm covering the storage part. ODA has redundant storage paths to the OS disks and also to the shared disks. As I mentioned, it has two mirrored internal OS disks with which are M2 SSDs. No moving part in that disk because it's practically just memory, and due to that they rarely break. But I mean, they can, and I will show you a quick demo what happens when they break. I have I simulated the failure, and regarding the shared storage, we have two host bus adapters on the compute node side. We have two controllers or IOMs. We have two expanders to have more disks in the shelf on the storage side, storage shelf side. And each disk is visible on two paths if you check it via multipath -ll command. Redundancy depends on customer's requirement from shared storage perspective and configured at ASM disk group level as part of the deployment. I mean, we call the shelf JBOD just a bunch of disks. And that's the reason we need a software solution to provide redundancy. And that's ASM, but does the job. It offers three different options. You can deploy your ODA with disk groups with normal redundancy, practically double mirroring, high redundancy, triple mirroring, and personally, I prefer the third one, the flexi redundancy, because it can provide you both double mirroring and triple mirroring as the redundancy is set at database level and not at disk group level. So when you specify normal redundancy, high redundancy during the deployment, it is done at this group level, and you cannot change it after the deployment. While when you have flex redundancy, you can create a database with double mirroring or triple mirroring, and another one with the same or different. It doesn't really matter, and you can change your mind afterwards and decide on, I need this database to have triple mirroring because it's so important for the company, or I need space and even the next shelf is in its way, but and we can add it to the ODA, but we still have to buy some time. So let's decrease the redundancy level to double mirroring, and everything is done by ASM behind the scenes. So this is Flex is the most flexible solution, as it offers both redundancy types. And like I mentioned earlier, redundancy level cannot be changed post-deployment at this group level. I apologize, I'm not sure if you can hear the background noise. I live close to an airport. Normal redundancy guarantees tolerating one disk failure. High redundancy guarantees the same for 2 disk failures. Under certain circumstances, these groups might survive even more disk failures, but it really depends on luck. I know it sounds weird in an IT word that I say depends on luck, but it indeed depends on luck, because we have very special partnership tables on ODA for ASM disks. I think 4 disks form, I mean, in one partnership, there are always 4 disks, and we have multiple combinations because we have 24 disks. And practically that means if 2 disks failed and they were partner disks and redundancy was set to normal, then the disk group would be lost. If they were no partners, then the disk group would survive. And I worked with customers who lost both of their disk groups, as they did not notice 2 to 4 disk failures over a long period of time. I'm talking about a year period. And ASR was not configured. They did not have proper monitoring, and this just silently failed. And as ASM tolerated the disk failure up to the 4th disk with normal redundancy, which was kind of a miracle. They lost the disk groups, and it caused a very long outage because they had to replace the bad disks first, then redeploy the machine, restore the databases, redo all the customization, and so on and so forth. And due to that, I strongly recommend, and actually that's the our best practice as well, to configure ASR, which stands for auto service request or something like that. So the ODA could file an SR automatically if it detects a disk failure, report the failure, and file a service request, a hardware service request, and the next day you wake up, and because somebody was ringing on the door, and the delivery guy is there and handing over a disk for you to replace it. So it's a pretty cool feature. Still, quite many customers don't use it, but I mean, it's very practical. If you cannot configure it for any reason, then at least you need some kind of monitoring that alerts you if a disk failed. Okay, so like I mentioned earlier, I have a demo that simulates an internal disk failure. I don't have a demo for shared disks, and it has a practical reason. I don't have access to physical machines. They are sitting somewhere in California. I would be happy to fly there and test it, but I'm afraid my boss would not sponsor it. But anyway, simulating a shared disk failure is doable as well, starting from 1921. Just by unplugging a shared disk, wait 5 to 10 minutes, you can you will see the status change with the ODA CLI show disk, and then plug it back, wait another few minutes, and you run the ODA CLI show disk again, and you will see that the disk is available again. So let me start the demo, just a second. And let me close just a sec. Okay. Do you see my screen?
Yeah. Yeah,
okay.
we do.
So we have empty devices on, I think, starting from X7, and or maybe earlier as well. And just the way we mirror the disk changed. At some point, we had software mirroring. Now it is done by the motherboard, I think, itself, and the CPU. And on X8-2, X9-2, the MD device for the OS disk is MD 126 P1, P2, P3, and P2 is the boot device, and P1 is the EFI partition. So let's move on. As you can see here, the state of the MD device is active. We use mirroring. Consistency policy is resync. And the actual device names are SDA and SDB, and they are in sync. Okay, let me speed this up. And I'm simulating a disk failure with this MDADM command. Basically, you can flag the disk as missing or dead. And if you query the status of the MD device, you don't see the SDB on the list anymore. And I mean, sorry, it is there just with the remove status. So you reboot the machine, and after reboot, you can see that it is syncing automatically. And that, I think, that would happen the same when you replace the bad disk with a good one. So we are rebuilding the disk using the good disk's content. And as this is an M2 SSD disk, the synchronization is quite quick. And basically, you get the active status back for both disks. And just to demonstrate that it works with both disks, so this is not the situation that when we always read SDE and we don't care about SDB. And I showed you a demo when I failed the SDB and rebuilt it. As I said, in a case when SDB is never used. Basically, it would not really matter what we do with the disk. I'm failing the SDA this time. And here you can see that all the clusterware resources stayed up and running. And even, I think at some point, yeah, these guys here are DB system guests, and they are also running happily. Nothing happened. The OS uses the SDB disks, and the reason I'm showing you this ODA DMCLI show disk, seemingly they are not related, but in fact, if the clusterware is not running, as it in a case it fails due to any kind of issue, then ODA DMCLI show disk won't work either, because Oak uses the clusterware as well. So, and after a reboot, we get the SDA device back as well, like in the previous case with the SDB. Okay, I think that's all about this one. And let's move to the software side. Redundancy. On ODA, even on single node machines, grid infrastructure is responsible to manage the resources, and along with RDBMS software, they provide various HA capabilities. From database type perspective, it offers 4 different options: real application cluster, RAC One node option. I will talk about a bit more later on. Single instance enterprise edition AJ and standard edition AJ. And I have to talk about MAA as well, which stands for Oracle Maximum Availability Architecture, which provides architecture, configuration, and lifecycle best practices for Oracle databases, enabling high availability service levels for databases residing on premises, cloud, or hybrid configurations. So it's not specific to ODA, it's more than that. Oracle and MAA team have been developing best practices and providing solutions to reduce downtime for planned and unplanned outages for more than 30 years. Best practices solutions are available to customers via books, technical briefs, blueprints. I also attached the MAA tech brief to this PPT. So when Sylvia will share it with you, then you can find the various, I mean, the MA tech brief to get more information if you are interested. And the point is, the main point is that we keep updating this regularly. A nice example for that is the technical brief, DataGuard technical brief for ODA. It gets updated very, very frequently. Sometimes for each releases, in some other cases in every other releases. We have MA integrated solutions on ODA. and I will talk about it, but practically we offer the MA gold tier option, which means RAC plus data guard. But like I said, I will talk a bit about it later. What drives the decision on deploying the right maximum availability architecture for our company? Two three-letter abbreviation. We are really good at Oracle in these three-letter abbreviations, I guess. But probably they are not Oracle specific either. RTO is required time taken for an application to recover from failure or to fail over and to become fully available to process user requests after a disaster. And RPO is the amount of data loss that our business tolerate in case of a disaster. And just a couple of examples. If we have a much better recovery time objective when we combine L0 and L1 daily incremental backups compared to having just one weekly backup, because we keep backing up our database and we lose much less data in case of a disaster. And RTO is much better using flashback database feature compared to restore database from backup after an accident or user error, or in case of a data guard, you don't have to rebuild your standby from scratch. You can use the flashback database option, and within minutes you have your standby back, and they can I mean, primary and standby can just sync up quickly. The lower the RTO, the higher the availability of application and the higher the cost of the DR solution. The lower the RPO, the lower the amount of data loss and the higher the cost of the DR solution. That's kind of the that's the equation, more or less. And I talked about the technical brief, MA technical brief earlier. In the technical brief, you can find the tiers that we, or the MA team defined. So we have bronze, silver, gold, and platinum tiers. And the bronze tier is when you have a single instance database, it's restartable by the clusterware. So if it fails, clusterware can restart it, and you have a backup restore solution. So you have a backup that you can restore in case of a failure. The silver tier is a database high availability with RAC plus application continuity, and the gold tier, I mean, plus the silver tier includes, like I mentioned, RAC plus application continuity, but it also includes the bronze tier. And same applies to gold tier. Gold tier includes the silver and bronze, but gold tier also adds to bronze and silver the database replication with active data guard. Or, I mean, MA suggests active data guard, but you can use normal data guard, which is included in the Enterprise Edition license. And the beauty of ODA is that it offers these tiers up to gold tier. The platinum tier is very complex, and usually customers implement it in huge environments, and then in Exadata environments, it involves Golden Gate, data guard, and I mean, like I said, that's a more complex and complicated solution. And we talked about high availability so far, But I briefly mentioned that MEA also considers providing minimum downtime for planned operations. And a nice example for a planned operation is patching. And if you have an HA ODA with RAC databases, then you can do rolling patching, which means if your database, application is completely RAC aware, and also the application can reconnect if in case of an instance failure or the instance goes down, because we are talking about the planned operation here, then the other instance is always available, or let me rephrase it. One instance is always available for application connections, and at any given time during the patching operation. And ODA offers that option, and we have the --local or -L option, I think, or maybe just -local in update server, and we also have it in update database. We also have the rolling option in storage patching, but sometimes storage patching is not available in certain versions, but the pre-patch report will tell you that right away. In case we need to update the firmware of the controller or expander of the shared storage, then unfortunately a rolling option is not available. If we just need to patch the disks, then we do it in a rolling fashion, but that doesn't mean your node will go. I mean, one node will go down and restart, and then we continue the patching and reboot the other node in a rolling fashion. Disk rolling patching means disk level rolling patching. So we detach one disk, we patch it, patch the firmware, and add it back to the disk group. And we continue with the next one till we patch all the disks. And that practically means no reboot is involved. Databases doesn't need to be restarted by the patching process, and so on and so forth. And let me show you something. There are two technical briefs at the moment included in the doc set. If you open the, let me show you. So you open the ODA documentation. On the left-hand side, there is an Oracle Database Appliance tech brief section, and there is a step-by-step guide for data guard configuration. It focuses on the integrated solution, but it also provides the steps for manual standby configuration and also the registration in the DCS stack for your manually configured data guard. And we also have another technical brief which has just been updated, and everything was verified that works on OL8-based ODA version as well. And it includes DB systems and application KVM deployments and examples and so on and so forth. So if you are interested, I can just recommend to take a look. Okay, so software level is slide 2. ODA offers KVM-based virtualization as well, so you can run the database on bare metal, but you can run the database inside DB systems, and you can also have application guests. So practically, you can have DB system guests and application guests on the same physical ODA. And as I mentioned earlier, we call it as a solution in a box offering. DB systems are special KVM guests that have fast access to the storage via VirtIO. It offers all database types like what bare metal offers: RAC One node, single instance with and without, high availability. In the current implementation, each DB system has one KVM guest running on each bare metal node, even for single instance databases. For RAC and RAC One node options, the reason is obvious why you need the DB system guest on each node. But for single instance databases, it's not straightforward. For single instance databases, the rationale behind that is to provide fast recovery in case of a failure. If DB system guest is running on the surviving node and our single instance database failed on the other node, obviously, or the other node went down completely, so not just the database failed, but the entire node failed, then there is no need to start the operating system, start the GI, the listeners, and all other resources inside the DB system guest to be able to start the database quickly. So in case of, I mean, if in the current implementation, it's enough to start the database in case of a single instance database failure. And on the surviving node, and that's usually a pretty quick operation. We just start the instance does the instance recovery, and the database is available for your application. Grid infrastructure inside DB systems are member clusters. That's so not normal clusters, which means they differ from the grid infrastructure that runs on bare metal. That practically means that they don't have their own ASM instances. And if they need any metadata from ASM about where this and that block is located on the disk, they have to reach out to the ASM instance running on bare metal. And for that, they have to talk to each other via private ASM network, which is configured over the private interconnect interfaces. So private ASM network is available between the bare metal host and all DB system nodes. And regarding the application KVM guest, they are black box KVMs from our perspective. So we don't know what is running inside them. And due to that, we cannot patch the operating system or maintain them inside the KVM guest. It's users' responsibility to maintain it, and also to install the OS inside the KVM guest and configure the network and so on and so on. But at the same time, we or ODA provides tooling to manage them in a sense that it creates the KVM guest at KVM level. So when you connect to it and you attach to the ISO, as I mean, it is mandatory to attach the ISO or a template or something to the create VM operation. When you connect to it via VNC, then you will see the install screen, and from that point, it works like you would do the installation on a regular physical machine, no difference. And the ODA tooling also offers the option to modify and the resources. So you can add, remove resources, memory, CPU, additional vDisk, additional network, and so on. For KVM guest monitoring, and the grid infrastructure is monitoring the KVM guests, and if one fails, the KVM guest process disappears, or the version doesn't show it as running, then the grid infrastructure will restart it if the failover option, or sorry, it will try to restart it, and if the failover option is enabled, then it can also restart it on the other HA node. What else? And when you restart a node, a bare metal node, and the auto start was enabled for the application KVM guest, then the grid infrastructure will start up your application VM automatically. I showed you the KVM the location of the KVM technical brief. If you are interested in this topic, please visit that link, and you can find really useful information in the technical brief. And I have two demo for this topic, software level HA. Just a second. Okay. Something is wrong. Is it visible?
Yes, it is.
Okay. So what I did, I created all kind of database offering on an ODA RAC One node single instance database with AJ and without AJ. And just a second, let me speed this up a bit. Okay, so the first one is a RAC database. RAC means the database is available for both nodes, and on both nodes we have a RAC instance running. It serves two purposes. Obviously, it serves AJ purpose. So if one of the instances died for any reason, and the application can reconnect to the surviving instance, then users might not notice any downtime at all. If the application cannot reconnect, you have to restart the application, but still the downtime is very short. The other purpose is, RAC provides scalability as well. And if your database is RAC aware, not database, sorry, I'm talking rubbish. If your application is RAC aware, then practically the resources are aggregated. And in under very special circumstances, you can reach linear scalability, which means if you have if your database is running on one node and provides n number of transactions per second, and you add another node which is the two node RAC, then you will get 2 times n transaction per sec. So it's a pretty cool database feature, and I believe it is still unique on the market. And the next one will be RAC One node. RAC One node, oops, just a second. RAC One. RAC One node is a bit similar to RAC, but they are not identical. So you can have 2 instances at the same time, one on each node, but just one is active. And usually, when you run the RAC One node database during normal for normal operations, then the database instance is only running on one node. And when you do the patching, then it can spin up the second instance, and you can do your database connections from application side can reconnect to the new instance. You can patch the node where the RAC One node was running earlier, and then you can do rolling patching. Long story short. The next one is a single instance database with high availability. That practically means the database is running on one node, and if it crashes, the clusterware can restart it on the other node, or you can also relocate it. But relocation also means it stops it on the node where it was running, and it starts on the other node. And single instance database without AJ, no AJ, means that you assign a node to this database, and it can run on that node only. And if it fails, the clusterware will obviously try to start it up a few times. There is a limit for that. And if all attempts failed, then it leaves it offline. So it won't try to relocate it to the other side, to the other node. Okay. And we have 2 DB systems, and like I mentioned earlier, even for single instance databases, we have the DB system guest running on both nodes. RAC provides the same functionality like on bare metal, the 2 instances inside both DB system guests and single instance database with HA. Let me show you. It's somewhere here. Database redundancy mirror. Where is it? High availability true, which means it can be restarted on the other node. And we have 2 KVMs running on this particular node. One has no AJ capability, and the other one has AJ capability. And if you look for auto start and failover in the describe VM output, then auto start shows yes, which means if the VM node reboots, then the clusterware can restart or will restart this application guest automatically, but it cannot failover. Same applies to the this application guest, like what I mentioned to single instance database without AJ. The clusterware will try to start it up on this node a few times and will give it up after a while and won't try to relocate it. And we have another KVM guest, and it shows auto start and failover yes for both, which means clusterware can restart it after a reboot, and if it fails, the clusterware will try to fail it over to the other node. Okay, and the most interesting part comes now. Okay. So I put all these offerings into, oops, I guess the letters are quite small. Apologize for that. So on the right-hand side, you see DB Monitor. That's a tool which was written by the same guy, Dominic Giles, who is the father of Swing Bench. The first graph shows the RAC, second RAC One node, single instance with AJ, single instance without AJ, DB system with RAC, DB system with RAC plus single instance AJ option. And okay, and you can see here that instances are running on this node. I mean, the single instance and also the RAC One node. For RAC, it is running on both, obviously. And come on. And also you can see that both application KVM guest with and without AJ are running on this node. And what I did, I triggered a crash or kernel panic with the systrigger. Actually, I did the same, but clusterware does if it has to reboot a node in an emergency mode. And you can see that only RAC 2 instance is running here. And the application KVMs were not running there. So the node crashed. Look at the graphs on the right as well. And as you can see, the DB monitor started to show that RAC One node, single instance without AJ, with AJ, without AJ are not available. And we will see the same for this guy. But for RAC, we did not see an outage. The RAC graphs look a bit weird because they look flat with a huge spike on inside the DB system and on the bare metal. But that's how the DB monitor works. So if you have a huge spike, then and you had low utilization for other DB weights or time on other DB weights, then basically the graph becomes distorted. And when the spike disappears, then all the other weight events will come back. And now on the left side, you can see that a single instance database AJ is running on this node, and also the RAC One node failed over. And also on the right-hand side, they came back. So for RAC, there was no outage. For RAC One node and single instance, you had practically same downtime. But for RAC One node, you can do the patching in rolling fashion. for single instance database, you cannot do that. So that's the main difference. And the single instance database without AJ is not coming back until the node which was rebooted boots up completely and start the database. And sooner or later, we will see that the single instance database with AJ also came back inside the DB system. Plus, on the left-hand side, the application KVM with AJ is running on the surviving node. So basically, everything got relocated, except RAC, because it was already running on both nodes, so there was no need to relocation. Okay, sorry, Sylvia, I think I'm running out of time, and seems I
no
still
worries,
have
no worries, Chris. Take your time. Yeah.
Okay. And the last slide for today, and actually I have two more demos for you. One will show the load balancing, which I mean, it's not necessarily considered as an AJ capability, but you will see that if you use load balancing and you load balance the database connections and they connect to both RAC instances and one dies, then at least the surviving instance, on the surviving instance, your connections are still available. And I'm just showing that to you to highlight the difference between normal behavior and the behavior when application continuity is configured. So that's the main reason I included that demo here. And I'm using again Swingbench for both demos to generate load. And just a second. Regarding connection failover and continuous service availability options, in the reference section, I included the technical brief for AC, application continuity. So if you are interested in these offerings, then please read the technical brief. It's also very useful. It provides actually 3 different kind of configuration examples. One is transparent application failover. That practically means, I think it requires a thick JDBC client or native SQLnet connection, and practically it can continue a select operation, but if there was an ongoing DML, then the network layer will throw an or something error message which tells the application, if the application can handle it, that the connection was broken, and the connection reconnected though, but the DML has to be re-executed from scratch. So if you were in the middle of a transaction, then included many inserts, updates, deletes, and at the end, the commit finalize all the changes, then you have to repeat all the DMLs, updates, I mean, inserts, updates, deletes from the beginning of the transaction. Application continuity, Honestly, I can't recall what's the difference between AC and transparent application continuity. But the technical brief can shed light on that if you are more interested. Transparent application continuity practically means that you define or you set up your environment with transparent application continuity. The application connects to a database instance in a RAC environment and RAC or RAC environment plus DR, or a single instance database plus a single instance DR. I mean, all kind of combination. And in case of a failure on the primary side and doing a switchover, or if we are talking about a RAC database, in case of an instance failure, the application can reconnect to the surviving instance and just continue where it left off. So another pretty cool feature in my view. I think it requires additional licenses, but probably it's included in Active Data Guard and also included in RAC license. So if you have these licenses, then it might make sense to play with it and activate it. So let me show you the demos. Oops. Okay, so what I did, I started a swing bench test with 200 connections or users, but in this case, at swing bench level, it means 200 connections as well, so no connection pooling. And practically you can see that on each node we have 100 connections, because by default, if you connect via scan, it does the load balancing. And I kill the first instance, and we will see that the DB monitor shows it as offline. Sometimes it shows it as offline. Sometimes DB monitor just crashes and you have to restart it in such a case. But now it survived, and we have 100 connection, and actually it is not trying to reconnect, so it stays as is. Okay, the second case is shows a 2-node RAC environment with a 2-node RAC standby. And on the right hand side, the two DB monitor graphs belong to the RAC primary, and the lower on the lower side, the two DB monitor windows belong to, or graphs belong to, the standby. And as the standby is in mount status, it shows initialization, shutdown, or shutdown in progress. Again, I'm using swing bench, but with a different configuration, because application continuity, I mean, the configuration XML file in swing bench for AC uses connection pooling. And okay. And as we have connection pooling, even though I have 500 connections at database level, it uses much less than that. So I think I'm killing the PMON. process of the second instance. And we can see that it went, this was the maximum size of the pool, 200. So it tried to open more connections, but it actually continues. And there is no error message here. And that practically means we did not lose connections, no error message, and our application did not even notice the failure. And now I'm doing a switch over to the other ODA. It takes a bit of a time because I think connection draining is also configured in the service, database service. So it is waiting. It is trying to shut down the instance with immediate, and it is waiting for the transactions to complete. We have some error messages, but these are recoverable errors. And as you can see here, switch over to standby, in progress or completed. So now it sees that something is wrong at the moment, and the database is not available. But transparent application continuity can wait. I mean, the time is configurable. And it keeps retrying the operation. Okay, I'm speeding this up a bit. Oops, and like I said, the DB monitor sometimes crashes when one of the instance disappears or went down, goes down. And now we can see that one of the first standby instance is running, and we will see that the other one will be available soon too. And still no error messages. There are warnings, but as you can see here, non-application AJ event received and ignored, different service name. So the message was published from database side, but it was not related to the service that I think that was a fan event probably that was sent out, and the application just ignored it as expected, and it just continues where it left off. I mean, there was some downtime from, and not downtime, sorry. The applications might experience it, or the users, as a short hang period. But again, it is expected if in case of a switchover, because you have to shut down the primary and start the new primary and switch the old primary to standby and start the synchronization and so on and so forth. So I think that's all. Like I said, I run out of time. Apologize for that. Any questions from anyone?
I think we have taken all the open questions. But I think we're going to leave 5 minutes again